Hello, my name is Abby Faber, and today I will be talking to you about the importance of cellulose. Cellulose is the most abundant organic macromolecule on Earth, and it's very significant in the human diet. Since cellulose is a polymer, I first need to talk about the monomers that make it up, glucose. Glucose is a 6-carbon chain with an aldehyde on one end and 5 hydroxyl groups on the rest of the carbons, but it mainly exists as the cyclic form. Carbon 1 has a strong partial positive charge because it's attached to oxygen. Oxygen has more protons in its nucleus than carbon, which will attract the electrons in the carbonyl bond more strongly, giving it a higher effective nuclear charge. The higher effective nuclear charge increases the electronegativity because it increases oxygen's ability to attract the electrons in the bond. The oxygen on carbon 5 has a partial negative charge because it's electronegative. One of the lone pairs on the oxygen on carbon 5 will attack carbon 1 and reduce the double bond of the carbonyl via a nucleophilic attack. The oxygen on carbon 1 then protonates, and the oxygen in the ring deprotonates to form the cyclic form of glucose. So this is what the final cyclic form of glucose looks like after protonation and deprotonation, with the hemiacetal in the ring. The hydroxyl on carbon 1 can either be in the axial position, where it's above the plane of the ring, or in the equatorial position, where it's perpendicular to the plane of the ring and below it. If it's in the axial position, it's in the beta form. If it's in the equatorial position, it's in the alpha form. The position of the hydroxyl group is what determines which polymer will be made. Glucose can form a bond between carbon 1 and the alcohol in carbon 4 via a nucleophilic attack called a glycosidic bond. The oxygen on carbon 1 is protonated, transforming the hydroxyl into a good leaving group, water. The oxygen on carbon 4 attacks carbon 1 and water leaves. Then, the oxygen connecting the two glucose molecules will deprotonate, and this is what the final dimer looks like, with a covalent bond between the two glucose molecules at carbon 1 and carbon 4. This process allows glucose to connect and form polymers. Polymers of glucose are also called polysaccharides. They are used for energy storage and support. One type of energy storage in plants is starch, which is made up of two polysaccharides called amylose and amylopectin. In amylose, the glucose monomers are in the alpha form and are connected by 1,4-alpha glycosidic linkages, which means there's a glycosidic bond between carbons 1 and 4. It is linear and unbranched. Amylopectin is also made up of 1,4-alpha glycosidic linkages, but it has occasional 1,6 glycosidic linkages that result in branches. They both take on a helical shape. Finally, we can talk about the synthesis of cellulose. Cellulose is another polymer of glucose. The glucose molecules are instead in the beta form, and they are connected by 1,4-beta glycosidic linkages. Every other glucose molecule is flipped over, resulting in straight chains. The chains are held by hydrogen bonds between hydroxyl groups. Hydrogen bonds form between the lone pair of oxygen, nitrogen, or fluorine of a neighboring molecule and hydrogen when they are electrostatically attracted to each other. The structure of cellulose gives it many unique properties that support plant structure. The glycosidic bonds are covalent bonds that hold the molecules of glucose very tightly together. Hydrogen bonds between the hydroxyl group allow chains to form a brick wall structure. The molecules pack closely into fibers with a tensile strength comparable to steel. This also keeps cellulose from interacting with water. These characteristics are very helpful because cellulose makes up plant walls, which provide structural support for plants. It allows tree trunks and stems to stand upward and defy gravity. Cellulose is very important for plants, but it's very important for humans as well. Cellulose, which is also known as dietary fiber, is highly caloric, and the enzyme used to break it down is called cellulase. However, the human body doesn't have cellulase, so we get minimal energy from cellulose. Instead, it goes straight through the digestive system to the large intestine. The increased solute allows water to diffuse into the large intestine via osmosis, feces swell, the intestine contracts and pushes the feces through. Dietary fiber keeps humans regular, and it strengthens the walls of the large intestine. If the walls don't contract enough, they can become weak and form pockets where digested food can collect and muscle tissue can die. This is called diverticulosis. If an infection occurs in one of these pockets, it's called diverticulitis, which can be very severe. Dietary fiber has also been found to reduce the risk of heart disease, stroke, high blood pressure, diabetes, obesity, and certain gastrointestinal disorders. Even though cellulose cannot technically be digested, it's still very important, so make sure you're getting some in your diet. It can be found in fruits, vegetables, beans, and whole grains, which are all plants. Here are my references. Thank you for watching, and I hope you enjoyed my video on the importance of cellulose.